मोल कॉन्सेप्ट फर्स्ट वाला है 1 AMU मतलब 1/Na ग्राम is equal to 1.6 into 10 to the minus 24 gram and 1.6 into 10 to the 27 minus 27 kilogram. Minimum molecular mass is 100 by the percentage into atomic mass. So दिया रहेगा उसका percentage into atomic mass, उसका atomic mass. And moles is equal to weight by molecular weight in STP and NTP condition, volume liter by 22.4. And empirical formula is equal to molecular formula by N. Vapor density is equal to molecular weight by 2. Percentage yield is equal to actual yield by theoretical yield into 100. Percentage purity is equal to pure mass by given sample into 100. 20 ग्राम CO2 अगर दिया हुआ है तो वो मास है. 20 ग्राम मोलिकुल ऑफ CO2 दिया हुआ है तो वो मोलिकुल है. 1 mole equals to 1 Na एंड R का वैल्यू कैलोरी में आता है 2 कैलोरी मोल इनवर्स केल्विन इनवर्स एंड जूल में आता है 8.314 जूल एंड लीटर एटीएम में आता है 0.082 लीटर एटीएम. 8.314 अगर प्रेशर पास्कल में दिया हुआ रहता है तो ये वाला यूज़ करना चाहिए. एयर प्रेशर बार में दिया हुआ रहता है तो ये वाला यूज़ करना चाहिए. नेक्स्ट रेडॉक्स रिएक्शन. रिडक्शन मीन्स गेन ऑफ इलेक्ट्रॉन, डिक्रीज इन ऑक्सीडेशन नंबर एंड ऑक्सीडेशन मीन्स वाइस वर्सा, मतलब इसका उल्टा. हाइड्रोजन विथ मेटल ऑक्सीजन नंबर -1 होगा. हाइड्रोजन विथ नॉन मेटल ऑक्सीजन नंबर +1 होगा. जनरली ऑक्सीजन नंबर ऑफ इनर्ट गैस 0 होता है, लेकिन जेनॉन का देखा जाए तो +2 +4 +8 एंड +6 रह सकता है, मतलब आता है उसका. ऑक्सीडेशन नंबर इज डायरेक्टली प्रोपोर्शनल टू एसिटिक स्ट्रेन एंड इनवर्सली प्रोपोर्शनल टू बेसिक स्ट्रेन. ऑक्सीडाइजिंग पावर F2 is greater than Cl2 is greater than Br2 and is greater than I2. बैलेंसिंग ऑफ रिएक्शन, फर्स्ट सेंटर एटम, फिर ऑक्सीजन एटम, फिर हाइड्रोजन एटम, फिर चार्ज. एसिडिक मीडियम साइड डिफिशिएंट ऑफ ऑक्सीजन, मतलब अगर देखा जाए तो इसमें देखो इसमें 12 ऑक्सीजन, इसमें 6 ऑक्सीजन. एसिडिक मीडियम अगर हो तो जिसमें साइड डिफिशिएंट है उसमें वाटर ऐड करना है, मतलब 6 ऑक्सीजन की कमी है तो 6 H2O ऐड करना है इधर. और बेसिक मीडियम हो तो जिसमें इलेक्ट्रॉन रिच है उसमें ऐड करना है, जैसे कि इसमें 6 H2O. फिर हाइड्रोजन एटम को मतलब बैलेंस करके और फिर चार्ज बैलेंस करके आपका रिएक्शन बैलेंस हो जाएगा. एंड नाउ सॉल्यूशन चैप्टर्स. सॉल्यूशन चैप्टर में फर्स्ट स्ट्रेन एस इज इक्वल टू वेट ऑफ सोल्यूट बाय वॉल्यूम ऑफ सॉल्यूशन. मिलियंस मीन्स 10⁻⁶, बिलियंस मीन्स 10⁻⁹. मोलरिटी m इक्वल्स टू n ऑफ सोल्यूट बाय वॉल्यूम ऑफ सॉल्यूशन, जिसमें से कि ये भी आता है वॉल्यूम मिलीलीटर में लिया तो ऊपर 1000 से इंटू करना पड़ता है. एंड ये भी आता है 10xt, x मतलब W इन सोल्यूट इंटू डेंसिटी इंटू मोलिकुलर वेट ऑफ सोल्यूट. ये डेंसिटी का मतलब फॉर्मूला है. एम भी कॉन्स्टेंट रहता है हमेशा. m1 v1 इज इक्वल टू m2 v2. नाउ मोलारिटी m इज इक्वल टू n ऑफ सोल्यूट बाय वॉल्यूम वेट ऑफ सॉल्वेंट इन किलोग्राम, और ग्राम में लिया जाए तो इंटू 100 ऊपर करना पड़ता है. इन टर्म्स ऑफ काई मतलब मोल फ्रैक्शन, m ऑफ मोलारिटी इज इक्वल टू काई ऑफ सोल्यूट बाय काई ऑफ सॉल्वेंट इंटू 1000 बाय मोलिकुलर वेट ऑफ सॉल्वेंट. मोलारिटी एंड डेंसिटी रिलेशन, m इक्वल्स टू 1000 m by 1000 d minus m into m2. m2 मतलब molecular weight of solute and m मतलब molarity and d मतलब density. Normality is equals to molarity into n factor. Solubility. Now solubility. Unsaturated solution, more solute can be added at given temperature. Saturated solution, no more solute can be added. Supersaturated solution, more solute can be added at high temperature. Factor on which solubility of solid in liquid depends. Solid in liquid can be exothermic or endothermic. First one is nature of solvent, like dissolve like. Next one is nature of solute. Covalent solid polar non-polar भी हो सकता है, लेकिन ionic solid always polar in nature. Third one is pressure, no effect because highly incompressible. Solid भी incompressible, liquid भी incompressible मान लो. And temperature, if exothermic then solubility is inversely proportional to temperature. If endothermic, solubility is directly proportional to temperature. Factor on which solubility of gas in liquid depend. Gas in liquid is always exothermic. First one is nature of liquid, like dissolve like. Nature of gas, more easily liquefiable gas will more will be solubility. Temperature, as it is exothermic process, so solubility is inversely proportional to temperature as exothermic. Pressure, solubility is directly proportional to pressure, is called Henry's law. Solubility of gas is measured in terms of mole fraction. So solubility means chi and directly proportional to pressure. So P is equal to K is into chi of gas. Chi of gas मतलब moles of gas by total moles. In case of dilute solution, N gas is very less than N liquid. So P is equal to chi is into N liquid by N gas by N liquid. And so limitation of Henry's law. Henry's law is gas in liquid. First limitation, pressure of gas not too high, temperature not too low. Gas should not undergo any chemical reaction with solvent. Gas should not undergo dissociation in solution. Application of Henry's law. At high altitude anoxia, lack of oxygen supply to tissue. Scuba diver, helium itna, oxygen itna and nitrogen itna. Henry's law is gas in liquid and Dalton's law is gas in gas. Pressure of gas is directly proportional to chi of gas. The pressure of gas is equal to chi of gas into P total. P total means pressure of A and pressure of B. So PA is equal to chi into P total, PV is equal to chi B into P total. Vapor pressure. Vapor pressure is directly proportional to temperature, inversely proportional to boiling point and inversely proportional to intermolecular force. Does not depend on surface area, mass, volume. Liquid in liquid solution. So Raoult's law. Here comes Raoult's law. PA is equal to PA pure pressure of PA into chi A, and PB is pure pressure of PB into chi B. P total is equal to PA plus PB, and here comes the equation. Boiling point temperature at which vapor pressure of liquid equals to pressure of atmosphere of external pressure. This one is the graph. Types of solution. Ideal solution, that's obey Raoult's law. Non-ideal solution doesn't obey Raoult's law. That means PA is not equals to P naught A into chi A. Non-ideal solution, one have positive deviation, one have negative deviation. In positive deviation, change in volume and change in enthalpy is greater than 0. In negative deviation, change in volume and change in enthalpy is less than 0. Here boiling point decreases, here boiling point increases. Example is H2O and methanol. H bonding of H2O decreases. H2O and HCl, intermolecular force and vapor pressure. Intermolecular force increases and vapor pressure decreases. Here is the graph of positive deviation, here is the graph of negative deviation. Now azeotrope. Constant boiling point mixture have same composition in liquid and vapor pressure. Cannot be separated by distillation. Maximum boiling point azeotropes equals to negative deviation from Raoult's law. Minimum boiling points azeotropes is equals to positive deviation from Raoult's law. So Henry's law is gas in liquid, Dalton's law is gas in gas, and Raoult's law is liquid in liquid. Gas in gas and liquid in liquid. When liquid is so volatile, it behaves as a gas. Their P total becomes equal to KH. Polygative property only depends on number of solute particles irrespective of its nature, size, physical state, and reactivity. So first one is RLVP, means relative lowering of vapor pressure. RLVP is change in pressure by initial pressure. So initial pressure minus Pi divided by P naught Pi is equal to chi 2. Chi 2 is equal to N2 by N1. So here are some equations. So RLVP is equal to N2 by N1 and W2 by M2 and into M1 by W2. Next one is elevation of boiling point, where boiling point of solution is greater than boiling point of solvent. So delta TV is directly proportional to molarity. Delta TV is equal to Kv into molarity. Here is the same graph. Molarity order is C have more molarity than B than A. So TV order and B boiling point order, that all are same. Next one is depression in freezing point. Depression means less than. So freezing point of solution is less than freezing point of solvent. So delta TF directly proportional to molarity and delta TF is equal to Kf into molarity. All the orders are same except freezing point of solution. It is the opposite or in reverse order. Here I have written molarity, delta TV, delta TF, boiling point of solution same order, but freezing point of solution opposite or reverse order. Osmotic pressure applied to stop osmosis. Pi is directly proportional to concentration, pi is directly proportional to temperature. So pi is equal to CRT. R means universal gas constant. Pi is equal to pi 1 means isotonic, but pi 1 is greater than pi 2. Here pi 1 is hypertonic and pi 2 is hypotonic. Pure solvent to solution. High concentration of solvent to low concentration of solvent. Low concentration of solute to high concentration of solute. Next one is Ventov factor. Ventov factor means I. I is nothing but number of particle after dissociation or association by number of particle before dissociation or association. If association, then I is less than 1. If dissociation, then I is greater than 1. Also defined as experimental colligative property value by calculated colligative property value. Here are some basics. Metals have electrolyte, non-electrolyte. For non-electrolyte, I always equals to 1. Example, urea, sucrose, glucose. For electrolyte, strong electrolyte and weak electrolyte. Strong electrolyte have 100% dissociation. Weak electrolyte have less than 100% dissociation. So a strong electrolyte, 100% dissociation. That means alpha is equal to 1. Strong electrolyte association. If association occurs, then I is equal to 1 by n, where n is the number of particle before the association. Like example I have given here. And next one is dissociation. Here I is equal to N, and I is the number of particle after dissociation. And for weak electrolyte association, I equals to 1 plus 1 by N minus 1 into alpha. And for dissociation, I is equal to 1 plus 1 N minus 1 into alpha. So here is some value with Fender factor, like RLBP is equal to I chi2, delta TF is equal to I kf into M, delta TF is equal to I km V into M, pi is equal to I CRT. Last one is abnormal molar mass. I is equal to normal by formula molar mass by abnormal molar mass. Association I less than 1, dissociation I greater than 1. So here normal mass is less than abnormal mass, and here normal mass is greater than abnormal mass. So association example is benzoic acid in benzene. Here example is benzoic acid in water. So here are the mole concept, redox reaction and solution. Thank you.